Okay, next on the stage is Stenver Jerkku, who described himself as a functional programming fanatic, and he will be telling us about his experience with RxJS. Let's give a round of applause.
Is the picture there? It's not pink? No? Thank you. So, yes, thank you, Oliver, for a great introduction. My name is Stenver Jerkku, and I'm going to talk to you about the hottest thing in the market right now, which is basically observables and reactive programming. If you've been in front-end development and go to conferences right now, it's been talked everywhere. And I'm basically a CTO in a company called eAgronom. Previously I worked in SaleMove, Tartu University, Norton, CGI. And like Oliver said, I'm a true functional and reactive programming advocate. I try to convince people that a lot of people for some reason think that functional programming is just something for math people, while it's not. It actually makes your code more maintainable, easier to read, understand, and in general, it's a good thing to actually learn and evolve your own way of thinking about programming in general. And another thing is that I'm a hardcore Dungeons and Dragons fan. I've been dungeon mastering D&D for years, so if you want to talk about D&D with me, just come to me afterwards and I can talk to you for hours. So this is basically the story, how we have figured out how to solve big asynchronous problems and remove state machines by simply thinking differently about events. And I work with applications which are heavily asynchronous. They're asynchronous every way you can imagine. Like application startup is asynchronous. Real-time communication between people through media and all that stuff is asynchronous. Real-time peer-to-peer thumb manipulation, all asynchronous. Data access, animations, view model binding, and everything else. You can make a lot of stuff asynchronous if you want to make your life difficult, and I work with applications like that. And asynchronicity is really hard. It's something like this. Like this kid is trying to catch this water, but when he gets his hand up, the water is already gone. And that's what I think that asynchronicity is in a nutshell. It's basically, it's really easy to do mistakes, errors, and shoot yourself in the foot in there. So, how many JavaScript developers do we have here? Raise your hands. A lot. Wow, okay, so you've all seen this kind of thing. Imagine this is basically an application where two persons can do peer-to-peer thumb manipulation and at the same time talk through video. Something like TeamViewer and Skype in browser. Now, when their engagement is set up, this is what it might look like. We have this prepare media, preload thumb, and in case the user hangs up before it's done, then everything is cancelled. And we can see this. There is this callback hell. It's like really simplified example of what it could look like, and still we have this callback hell going on. And the bigger it gets, the harder it is to follow and reason about and make mistakes. JavaScript developers are usually very familiar with that. Also state. There's a random state all over the place. State can be changed from different places, and it's hard to reason about where was the state changed, and it's very easy to get into a place where you can't actually understand what changes your state, or your state somehow gets into undefined state. So state in callback hell is really bad thing. Error handling. We as developers know that errors are a way of life. It happens all the time, and we love to fix that or manage that with try catch. With callbacks, we don't have that luxury. We usually just need to build our own error handling, which is usually brittle, can easily break, has lots of bugs, and is never really perfect. And finally, memory leaks. It's really easy to memory leaks. I purposely added add event listener in here in case the user hangs up before the preload is done. And if we cancel and we don't remove this event listener, then we have a memory leak. And if you have a single page application, and a lot of people are doing single page applications these days, then these things start to add up, and eventually you have a leaky application, and then you need to start debugging it. And debugging JavaScript memory leaks is hard, and it takes a lot of time. Finally, of course, race conditions. Whenever you're dealing with asynchronous code, it's by definition has race conditions inside it. So, let's talk about reactive programming. Who knows what reactive programming is? Raise your hands. There are a few people. Okay, then this talk will be boring for you. There's something upstairs. For the rest of you, let's find out what is reactive programming, because it's actually really difficult to explain to people what reactive programming is. When I went to the World Wide Web, the place where the entire mankind's information is, I found this nice picture. There's like push, pull, have next, got next. But in reality, it doesn't really tell me anything. It doesn't tell me what is reactive programming, and I'm not any smarter looking at this. So let's dig deeper. Reactive manifesto, it's responsive, elastic, resilient, message-driven. There's boxes with arrows around them. But I'm sure the project manager will love this, but it won't help you do reactive programming. So we need to go deeper. Microsoft is actually one of the inventors and first drivers of reactive programming, and they created the library Reactive Extensions, which is what this talk is mostly about. And they said that, in essence, reactive programming is observables plus Linku plus schedulers. Now, if you work with .NET for years, then maybe you understand what it means. I personally, in the past, used to work in .NET for 2 years, and that still didn't ring a bell for me. So I'm sure for most of you it doesn't really explain anything. So let's go forward. Stack Overflow has this huge comment on what reactive programming is. It's like 2 pages, and it's really detailed, and if you read it, I think top comment to that answer sums it up perfectly. I've been programming for 20 plus years, and your answer leaves me baffled. Please reply in English. Right. So maybe the Rx API will help us out. This is the method called flatmap latest. We use it everywhere. It's extremely useful. Observable sequence which transforms the items emitted by an observable into observables and mirror those items emitted by the most recently transformed observable. Holy cow! Raise your hand who understood that. I didn't either. Okay, let's talk about reactive programming. This is my attempt to explain what reactive programming is to you. And if I didn't do a good job, then come to me later and tell me that what's missing so I can improve on this. Reactive programming is basically programming with asynchronous streams. Does anybody have an idea what an asynchronous stream could be? Just say it out loud.
Keystrokes.
Keystrokes, that's right. Mouse clicks. Those are all asynchronous streams. Also, events coming from the server, very good. And these are all asynchronous streams. They're basically stuff that happens asynchronously. You can't control them. User sends you data. You need to be able to handle that. And what else can be a stream? Eric Meyer, one of the founders of reactive programming, said that what is the difference between an array and an event? Fundamentally, they are actually both collections. An array is actually just a set of items. An event is a set of items coming through time. But they're all fundamentally collections. Now, if the events and the arrays are both collections, and events are fundamentally also a stream, then we can actually say that arrays are also a stream. And since everything can be composed of arrays, and array is both a collection and stream, then all the arrays our stream. And like I said, everything can be composed of arrays, and it's really hard to wrap your head around it. But if you start thinking about it, then at one point you get it, and you reach to a point where you understand that everything is a stream. You get this same moment. Variables, user input, properties, caches, tree structures, everything is a stream. You scroll down the Facebook feed, you reach the bottom, Facebook sends you new data, new posts, it's a stream of new data. User clicks, like, stream of likes. Chat notifications, somebody sends him chat messages, stream of chat, everything is just a huge stream. And it turns out, since arrays are really cheap, you can represent everything with arrays, you can compose arrays, and since streams are basically just an arrays and vice versa, then streams are actually really cheap. And this is where the functional magic kicks in. You can do a lot of nice functional stuff with arrays, and you can do all the same functional stuff with streams. You can take a stream and use it as an input to another stream. You can take two streams and merge them together. Exactly the same way you can do with an arrays. You have two streams of data coming in, and you merge it into a single stream. You can concat streams. Taking two streams, concating them together, just like an array. And there are all kinds of other ways. Everything you can do with an array, you can do with a stream. Streams are functional, just like arrays, and they can be mapped. I mean, we all know what mapping means, right? I don't have to explain it. Even Java developers by now know what mapping means. It's taking a function and applying that function to every element in the collection. Filtering, you basically take a function, apply that function to every element in the collection, and whenever there's a true, you keep that element. When there's a false, you throw it away. Debouncing, extremely useful example. You can listen to a stream of events, and when an event comes, you don't immediately use it. You wait for a little time, you debounce it, and see if any other events come after it. If no events come after, like after our first one, we immediately put it to the new stream. In our second column, we can see that new events come after the first event. So we don't immediately fire the event, and then we fire the last event after the pause. And debouncing is one of the very useful things you can do with streams. Streams can be completed. This is a very useful thing for streams. I'm going to get back to it later, but basically it means that once you have what you want from the stream, you complete it, you close it off, and it's automatically cleaned up. There's no memory leaks. All the listeners are closed. You don't have to worry about it. So you have a stream of events. You only take the first one. After that, you're done. All the streams are cleaned up. Memory, there's no memory leaks. Everything works magically. Take until. You can have two streams and say that whenever an event happens in the second stream, then you stop. Your stream is completed. You don't care what happens next. So both of the first streams clean up, and you only have the second. You took all the data you cared about. And this is just the tip of the iceberg. There's loads of things you can do with the streams. The Rx documentation is huge, and there's lots and lots of cool stuff you can do with it. So RxJS is a JavaScript implementation for reactive programming. There are other libraries out there, but this is the one that's the hottest right now. It was started by Microsoft in .NET, and it got so good and so popular that now it's community-driven to a lot of other languages. I'm going to focus on JS, but rest assured there's Scala, Java, Ruby. I heard there's Python programmers here, so there's one for Python, and it's very cross-platform in that sense, or cross-language, sorry. And in Rx, streams are called observables because you observe them. They are observed. So you grade observables. In this case, we grade the stream of a single string. Even though it just returns a single string, it's a collection of one item, and collection of one item is still a collection, and we treat it as such. We don't acknowledge that it's a single item, we acknowledge that it's a collection. Functions listening on events are called observers. So in this case, we basically make a jQuery get JSON request to the server, and we have three methods on it. Observer onNext, which is when something comes from the server uncompleted, when the entire thing has finished, and onError in case something goes wrong. And you subscribe to observables to start listening for events. So in this case, we have the request stream. We use it to get the JSON from the server, turn it into response stream, and once we subscribe to the response stream, then it all starts flowing and starts working. So some of you may have been listening are like, I mean, Stenver, asynchronous. Why are you talking to us about this technology? It's already been solved. Why not just use promises? And promises are great. They are first-class asynchronous values. You can chain together the tens. There's guaranteed one callback call, fulfilled or rejected. Handlers are all called asynchronously, so you can do all the asynchronous operations you want on them. And once a promise is settled, it will always return that value, so it will not make another request or computation. That value is already set. If you want a new request, you create a new promise. Promises are great, but let's take this example. Consider you have an application, like a Dviewer application, and we want to know that when a user clicks on an element, then we want to check that if it was a clickable element. If it was, then we send it to the other side, to the other user who's in the another computer. So this is how it could work with promise. But promises are not perfect. First question, how do you cancel a promise? Now we heard from Phil that they're trying to improve it, and there's some specking going on, but as of right now, promises don't support canceling. And there are libraries that try to get around that, and you can use them, but why not just use observables, right? And the other question is, what if I don't care about the return value? Like, let's consider that our click was actually a double click, and now we sent out the first click, and we don't care about the double click anymore. And basically, we're going to have to use some set timeout methods or some other nasty things to make sure the single clicks don't react. At the same time, we want your application to be as responsive as possible. So this is also a problem, and there are many cases where this can become a problem. And final thing is, what if you want multiple values returned? Promises are great for single values, and they're meant to be for single values, but they do not have good support for multiple values, and this is where promises are lacking. So coming back to our Ajax request example, if you look at this, this is actually, it has everything that the promise requires. It has onNext immediately followed by onCompleted, almost the same, and it has onError. But promise, like I said, is meant to return a single value, but observable can read all values, everything as a stream, as a collection, and promise is actually simply an observable with a single emitted value. If you start thinking about it, you understand that promise is actually, or observable is actually promise plus plus. And in fact, observables and Rx work so well together with the promises that you can write the entire thing like this: Rx observable from promise get JSON. And going from this, we can treat the promise results as a collection, because a collection of one item is still a collection, and it doesn't really matter. There's no like performance overhead or stuff you should really be worrying about. And we can cancel streams. We can send multiple values. We can do everything that the promise was lacking in. And you might be saying that this is all nice, but show me the code. So let's say you want to have a stream of double-click events. And let's say also say that 3 or more clicks also count as double clicks. Now, how would you do that in traditional imperative and stateful fashion? Does anybody have any ideas? It would probably involve set timeouts, state, some callbacks, all that nasty stuff. And testing that would be a pain, a true pain. Now, do you think observables would make this easier? This is what it would look like with observables. You listen for a click event, and on that click stream, you buffer the stream. And in the buffer, you throttle all the events that happen within 250 milliseconds. You map over the results, you check the length or map the length of each array that was buffered, and you only keep those that were longer than 2 or longer than 1. If this was difficult to grasp because it's like code that might be unfamiliar, then this is what it looks like with graph. First of all, we have a stream of events in the top line. We buffer and throttle it, which means in the second line, we have put them into distinct small arrays where they are buffered and throttled. Now we map over that list, and we get the length of every array of events that happen. And then we filter out only those that we care about, which in this case are equal or greater than 2. And that's how simple it would look like. What about memory leaks? Like, consider an example when you want to, for some reason, console log out all the mouse moves until user does a click. Now, this is what it might look like with traditional way. With observables, it might look like this. You listen to the mouse moves events, and for each event, you console log it out. And for the unsubscribe or completing the stream, you listen for click events, take only the first click, and now you start subscribing for it. Whenever an event happens in the click stream, you dispose of the mouse move. And since we already only took the first click, then our click stream is also disposed. Now you might be saying that this doesn't look that much easier than a traditional way, but it actually gets simplified a lot if you start thinking about it. And we can write it as such. So we listen for mouse moves, we take until the first click event comes, and we simply console log out all the results. And the streams, once they're completed, until fires, all the streams are cleaned up, there's no memory leaks, everything works magically. Coming back to our first example, where we had this application where you can reload the DOM and set up media. It was a really ugly code. With Rx, we could rewrite it something like this. DOM reloader, reload, take until we have the hang up clicked, and we combine all this stuff together, and we subscribe to it. It takes some wrapping around if you read it, but once you get familiar with the code, it's really easy to read. So, and one thing I want to really note about is that testing with Rx is very nice. It actually provides you excellent tools to do asynchronous testing in a synchronous way. Imagine that. All the code you had where you did some set timeouts or used like, I don't know, sign on clock restore or whatever there was where you had fake clocks. You can now do it all asynchronously thanks to the Rx. You don't have to use thumb methods or stuff like that. You can emulate time with time scheduler, and all these testing tools work very well with all the existing JavaScript testing frameworks. For debugging, there's this do keyword, which you can use to cause side effects, like logging. In case of our mouse clicks, we might want to just log out when the click happened, and we want to maybe log out when the click counts come. And maybe we don't want to log out, but maybe we want to actually send this logging data to the server. You can do that with the do effect and cause all these side effects. There's lots of other helpful tools like timestamps and stacks, but I won't get into them. You can look at them yourself. So, at the state we're in right now, we use observables everywhere because we even use them on the server side. There's like data starting from the database, it's map reduced, sent to the client, where it's map reduced and manipulated over there, sent back to the server. So it's like streams of data going everywhere and treating it as a stream. I mean, a lot of applications I see wouldn't actually be possible to do. It would be not impossible is the wrong thing to say. It would be extremely complex to create those applications without these really useful tools. And the RX revolution is taking over the world. I already mentioned it's in a lot of different languages. It's in every mainstream language you can think of. I haven't checked C, but I wouldn't be surprised if it's in C too. And you can use it in server, in clients, but it's mostly meant for doing asynchronous stuff, and that's where it really starts helping you out. And the big players are using it, like Angular ships with RX. If you read the Redux documentation, it mentions RX all the time. Cycle.js ships with RX. Companies like Netflix, Microsoft, Google, and others use RX. So this thing is used by a lot of big players. And these are all the references I took. You can read all kinds of helpful tutorials from there if you want. I'll put the slide to Twitter. And that's it.
Thank you, Stenver.
Thank you.
Thank you. So, one question I have is, when I read the description of your talk, it mentioned that you moved to RxJS in SaleMove, your previous company. So what triggered this move? Did you just research and realize it's a good solution for what you were doing there? Or was there a more specific trigger that just was like, that's it?
Well, actually how it happened was that in a long night, I was reading around Hacker News. I stumbled upon this wonderful presentation made by a guy in Netflix where he talked about RX. I watched it, I sent it to my colleagues, and one colleague got really excited about it and just started introducing it, and then it started spreading like a cancer all around the company.
Okay, so you're helping it will spread among us as well.
Absolutely, absolutely. If even one of you starts looking at and learning RX, then I consider this talk a success.
Awesome. Okay, do we have any questions from the audience? We have one from Jordan.
Thanks. Awesome talk. Streams everywhere, so two quick questions. What is the coolest streams implementation you have seen? Like, which implementation goes the furthest with the features? And what's next for streams?
Okay, so you basically asked that what is the coolest implementation of streams? Do you mean like application of the RX library or capabilities of RX?
Yeah, I mean like Java has one, JavaScript has some.
Okay, so basically in case of JavaScript, there's a new version of RX coming out. The beta is already there, and you can already use, and actually we already tried it. And what they're doing is basically they took a critical look of the entire RxJS library, and they looked at it and saw that there's a lot of things in there that work great with our reactive programming paradigm, but actually in JavaScript, since JavaScript is a language the way it is, we all know what JavaScript is, it's kind of funny in that sense, you can do everything you want in there. Then in JavaScript you can do actually some stuff a lot more efficiently, and in the beta they actually rewrote a lot of the core functionality of RX, and what they're trying to do is making it even simpler to use in JavaScript. And one of the other things they're doing is that they make sure that each module you have in RX is packaged separately. So in each of your classes or each of your closure scopes or whatever way you like to structure code, you can only make sure you import only the parts of RX you're interested about. So if you want, you can only import the map method. If you want, you can only import flat map. If you want, you can import the entire library. But basically, this allows you to make sure that your final JavaScript package is actually a lot smaller and easier to maintain.
Okay, so I get you're saying that the next for streams in JavaScript at least is to integrate with kind of application level stuff. By the way, I think my favorite implementation is from Go, really kicks ass. Thanks.
Okay, do we have any more questions from the audience? We have one from there.
Has there been any movement to make this native on the web?
Well, that's actually one of the things that the next version also does, that they don't in the next, in ECMAScript 7, if I'm correct, they actually have observables natively. And Rx, the new version of Rx, does its best to build on top of that and make sure they don't have to do extra work that's already been done for them.
That's awesome. Object.observe without spectrum. If you talk about object.observe, they spec it in that observables.
Yep.
Okay, that's it. Let's give another round of applause to Stenver.